Hello guys. So in this video we will look at another way to get a characteristic equation of a circle. This is another way. So it will look quite differently compared to the previous characteristic equation you saw. So in all these cases we are implementing the properties of circles. So in the first case, the first characteristic equation of a circle you obtain was when the center is at A, B and a radius. When the center of a circle and the radius is given, you know that each point on this circle uh, would be r distance away from the center. So in this case you obtain the characteristic equation as x squared plus y squared minus 2ax minus 2by plus a squared plus b squared minus r squared equal to 0. So in this case we implemented the fact that any point on the circle lies at r distance away from the center. Let's see uh, let's see what else, what are the other properties of a circle that we can use to obtain uh, 10 characteristic equations which are different from the previous case. So in this case, this is a second case, we will implement the idea of okay, I'll get to it later. Let's say that when two points uh, when 2 points are given, when 2 points are given, uh, 2 points are given in the circle, right? Okay, let's forget about this. Let's say when there's a diameter AB, right? When the coordinates of A and B is given. Now, when the coordinates of A and B, AB is the diameter, this is the diameter, and the coordinates at A and B is given x1, y1, x2 and y2. So you are given the coordinates of A and B, and AB is a line segment which is the diameter of this circle. When these two are given, how do you find the equation of a circle? Equation of a circle means that find all the xy points, all the coordinate points which lie on this circle. So in this case, I'm gonna implement the fact that the line segments I draw here, let's call this P. So AP is AP line is perpendicular to PB line. So this is the property we are going to implement here. The gradient of this is perpendicular to the gradient of this, right? Sorry, that was wrong. So the line AP is perpendicular to PB. That is a fact we are going to implement in this case. So what is the relation between the gradients if two lines are perpendicular? Let's say that the gradient here being m1 and the gradient here being m2, right? So you know that if this is perpendicular, so choose any point on the line, you know that AP is perpendicular to PB. So m1 into m2 must be equal to -1 because these two lines are perpendicular. AP is perpendicular to PB. Now how do you get the gradient m1? m1 can be obtained. This is m1, uh, y minus y1 divided by x minus x1, and m2 can be obtained by, let me subject y here again, y minus y2 divided by x minus x2. So it doesn't matter, this is also equal to y2 minus y, x2 minus x. So I like this expression because it's you will see in a moment why. Now we'll have to multiply these two. So y minus y1 over x minus x1 into y minus y2 divided by x minus x2. This is equal to minus 1, right? This was obtained based on the fact that the gradients of these two lines, the multiplication of the gradients of these two lines is equal to minus 1. Now we can cross multiply this. So I'm gonna multiply the two numerators here, y minus y1 into y minus y2 divided by, let me just take this to the other side, minus x minus x1 x minus x2. I can take this into the other side and you get y minus y1 y minus y2 plus x minus x1 x minus x2 equal to 0. So this is another characteristic equation of a circle. So you can simplify this more, but this is in the simplest case because it is in the factored form. So if you expand this, you would obtain, if you expand this, you would obtain y squared. Here you know this is a quadratic equation in y, this is a quadratic equation in x. If two factors are given of a quadratic equation, you can write it as y1 plus y2 y plus y1 y2. You can write this x squared minus x1 plus x2 x plus x1 x2 is equal to 0. Then you can couple these, x squared minus x1 plus x2 x minus y1 plus y2 y plus y1 y2 x1 x2 equal to 0. You can see here that you have the quadratic terms here, y squared plus x squared, then x terms and y terms, then you have a constant. So this is quite similar to the previous case. Okay.